The government of Denmark backtracking on an order to cull millions of minks in an effort to contain an apparent mutated strain of the coronavirus. Well, the Danish government now says it has no legal authority to order that they be killed en masse, so officials are making it a recommendation to farmers instead, and we understand that they are doing so. Well, this mass culling began last month over fears that the mink were getting infected by a coronavirus mutation. CNN's Isa Suarez has the latest, but first a warning, you may be disturbed by some of the images in her report.
Mink farms across Europe are raising alarm in the fight against coronavirus as farm workers bring the virus to the animals, and in these cramped conditions it could spread like wildfire. Nowhere is this concern more acute than Denmark, where it has led to this. The government recommending that farmers cull all 15 million mink across 1,500 farms.
I cannot underline enough how seriously the Danish government takes this situation. The Danish government has, for the moment, the global pandemic reached Denmark, chosen to act fast, decisively, and with clear commitment that we would rather go a step too far than take a step too little to combat COVID-19.
Scientists have noted a small mutation in the virus in some of the people and minks affected. That's normal, but it's unclear if it's meaningful.
You have a lot of minks in those farms on a small area together, so you have a lot of transmissions. So in the end, you have far more mutations that you would have in the same region in the human population. So the risk that you have a mutation that could be more dangerous is higher.
Europe's CDC fears such a mutation may have implications for immunity, reinfections, and the effectiveness of COVID-19 vaccines, but says there is currently a high level of uncertainty over this. The World Health Organization, meanwhile, says further studies are needed.
We need to wait and see what the implications are, but I don't think we should come to any conclusions about whether this particular mutation is going to impact vaccine efficacy or not. We don't have any evidence at the moment that it would.
Some scientists argue, however, that the fear is overblown because so many mutations have already occurred in humans.
I don't really believe there's an extra risk of these mutations happening more often in minks than in humans, that they could create some kind of new, different superstrain.
Danish researchers are now combing through their testing data to better understand the mutation. The danger still unknown, but in Denmark, they are taking no chances. Isa Suarez, CNN.
Well, I want to bring in Stelios Moskos, who is, or certainly used to work for Pfizer, and is now currently an associate professor of molecular virology at Northumbria University in England. It's good to have you with us, sir. Are these concerns of an animal like a mink acting as a sort of what's known as a reservoir of infection, are these concerns warranted, to your mind?
Yes, simply put, they are very much warranted. If we have a virus that's circulating in an increased number of individuals, human or animal, then the chances that the virus will mutate are higher. The mink farms in Denmark are actually really crowded environments, and just like in the human settings, the virus will go through wildfire through these crowded mink settings. So the consequence of that is that the virus may become endemic, as it's known, or adapted to live in mink, and then hop back to humans. Now, we've already seen that the virus can go into mink and back to humans because it came from the humans in the first place. Therefore, having ongoing transmission in the background in an animal population means that the virus is given a space and time to adapt, change, and therefore potentially come back in the future in a slightly different form. That's why we need flu vaccines every year, because the vaccine for flu stops working on an annual basis, because flu sits in birds, sits in pigs, sits in all sorts of animals, and then it just hops back to humans, and here we go again and again and again. And that's what we're trying to avoid.
Well, that's fascinating. Let's talk about vaccines then, because after Pfizer, your former company, announced alongside BioNTech that their vaccine had proven to be over 90% effective, you tweeted an excerpt of an article saying, and I quote here, "Although it is a bright spot in the battle against the pandemic, key information about the vaccine is not yet available. There is no information yet on whether the vaccine prevents severe cases, the type that can cause hospitalization and death, nor is there any information yet on whether it prevents people from carrying the virus. These are clearly all important points. Explain further, if you will.
Yes, surely. I'll start with the second point about the carriage of the virus. Let's assume a situation that we're thinking about students going back home for Christmas, and maybe our government here in the UK, maybe the US government, maybe some other government decides to go away and vaccinate all these young individuals before they go to their parents, who might be elderly themselves, or the grandparents for the festivities. What happens next is, if the virus is still able to move from the student to the parents and the grandparents, then these individuals will get sick, and the vaccine hasn't protected those other individuals. So it's important to establish that whomever gets vaccinated can't get infected and transmit the virus. They might be just protected, and they may never get a fever, they may never get a cough, they may get a cough or a fever and get something worse as well, but not die. That's then where we go into the first question of how protective is that vaccine? So if we look at the entry on clinicaltrials.gov, where the clinical trial from Pfizer and BioNTech is registered, there's a lot of nuance on what we mean by an effective vaccine.
Right.
And it's not very well described. So does it mean that they get a bit of a cough, or does it mean that they have to be put on a ventilator? We just don't know, and that information is not there. And consequently, we don't know what protection really means.
Right, and these are clearly extremely important points. Very briefly, when do you think we will get a vaccine? When will a vaccine be ready for all of us?
If I had that crystal ball, I would perhaps do some investment in the right companies as well, and you may read into that statement whatever you like, but I'm afraid nobody can actually give you a straight answer on that one, okay? It's a brand new virus. We don't know what its cycle it's going to be with regards to escape mutants through reservoirs, etc. We don't know how long vaccines that are being developed right now are going to last in protecting you. It might be 6 months, it might be a year, it might be a decade. We just don't know. And we don't know how fast we will have the data that will allow us to say with confidence, we've done this.